looking at day 5, and our question of the day is, let's investigate polynomials written in factored form. So we're going to do the warm-up and see what we notice and wonder. This out. Did you read the bullet point at the top? It says, let's investigate polynomials written in factored form. There's 2 ways that you can write a polynomial. We've already started to look at one of the ways. So we've got a couple different days, something that was like, y equals 3x squared plus 2x plus 7. This is not written in factored form. Can someone tell me, as a quick review, how many terms are there in that polynomial? How many terms are there? There are 3 terms. What is the degree of this polynomial? The degree is 2. How did I figure that out? How did Matt figure that out? A highest power, right? And what's the leading coefficient of this polynomial? The leading coefficient is the leader. This is standard form, highest to lowest power of x. What is the constant term? Okay, so let's try one more of those, because this is what we did last week. Let's say I have 4x cubed plus 2x to the 4th plus 9. How many terms are there in this polynomial? 3 terms. What's the degree? The highest one is 4. What's the leading coefficient? This 2 right here is the leader. If this was written actually in standard form and order, what's the constant term? 9. And last class, we talked about adding 2 polynomials together. So when I actually go and add these together, what would I get as my answer? So I only have one of these x to the 4th terms, so I have 2x to the 4th. I only have one of these x cubed terms, so I'd have 4x cubed. I only have one of these x squared terms, so plus 3x squared plus 2x. I put constant terms that I could add together for 16. So when you add together polynomials, you only add together their like terms. So if I had had another x squared, I could have added them together. But this I didn't. So look how that is different in today's, these are called factored forms. And it says, what do you notice and wonder about these factored forms? So they're giving you 3 examples. I want you to take a minute, either on your own or with a partner. You're comparing the factored form here with the graph of the polynomial here. What is something you notice? We actually studied this during quadratics, and you should actually know something, not just notice something. So give me a link between the factor and the actual graph. I'll give you a minute before we talk about it together. Each of the points in the parentheses are one of the points on the x-axis. They are directly linked, but what value x plus 5 shows up on the x-axis? -5. What point for x plus 1 shows up on the x-axis? -1. So how can we rephrase what Orion said? Each of the factors gives you what? The opposite of the x-intercept. Does anybody remember why that is? How come if I have x plus 5, -5 is showing up on the x-axis? Someone has to remember this from Unit 3. Nope. Why, though? I'm asking, why does x plus 5 become an intercept of -5? Okay, that's one idea. Transformation rule, x plus 5 goes to the left is an idea. What is this as a full coordinate? -5 comma what? 0. What happens when I plug in -5 into all these parentheses? I get 0 here times -4 times -7. What's 0 times anything? 0. So because the factor, or sorry, the 0 is -5, when I plug it in, I get 0. Same thing with -1. If I plug it in here, I get 0, right? Because I get a 0 right here. Did it hold true for all of these? This one was at -5. This one was at -1. This one was at +2. And the bottom one, -4, -1, and 2. So I feel like in quadratics, we didn't quite master that type of problem. Here was one that we had trouble with as well. Can anyone predict for me what my x-intercept would be if I had x times x plus 1 as my quadratic? This one is easy. What is this x-intercept? -1. What is that x-intercept? Anybody remember? Why is this -1? Because when x is -1, this becomes 0. What? So when x is 0, that is actually one of the x-intercepts on the graph. So kind of linking the factored form to the graph is the idea for today. All right, so that was just the warm up. So I don't know why the directions for 5-2 are printed on the bottom, and then the work for 5-2 is on the next page somehow when this got formatted for printing. So it says what values of x make these equations true. Find all values of x that make the equation true. I think this next year is at the start of the year. We already spent a lot of time on this when we studied quadratics. So I think this is a way for students to review their work with quadratics for Algebra 1, starting the year into Algebra 2, where this is not going to get covered. So could you take a few minutes with a partner? There's a few tricky ones on here, but let's just, what would the answer be to number 1, just to make sure we know what we're doing? X equals what? How am I going to take that answer? What values for x make the equation true? -4. What else? -2. Or what's my last answer? +1. -4, -2, or +1. So you're going to take a little bit of time and try 1 through 8. There's going to be a couple that you're unsure of. Asterisk those. I bet everybody in the class will have the same question about 2 or 3 of these different ones. Sure. So it would have been kind of easy like number 1 was. Does someone want to tell me what they got for number 2? X equals what? All right, did you get all those? -4, -2, 1, and +3. Okay, number 3, I already put a suggestion up on the board because what does the squared mean? This means writing x plus 4 times x plus 4. What is the x-intercept? -4. We're going to figure out how the graph changes. It's called multiplicity when you have more than one factor occurring at the same time. But all you would need to say is that -4 and -2 would be your two x-intercepts on the graph. We're going to actually learn that because it was x plus 4 squared, this actually kind of makes a bump like a parabola right at that x-intercept. So a bump that looks like that. Rather than just cutting through the axis like normal, it actually creates like a little parabola bump at the axis. So there's a thing called multiplicity that we're going to talk about when factors show up more than once. What did you get for number 4? This is one that was tricky on our test. Does the -2 offer any new x-intercepts? It's just the stretch factor and it makes it concave down, but it doesn't offer any new x-intercepts because -2 itself can never be 0. So you should have said what? +4, +2, -1, and -3. So seeing a number in front does not change any of your x-intercepts. Okay, this one was tricky because this one you had to do a little bit of work on. 10 is the only one that you can read without doing any work. So x equals 10 was one of the answers. Does anybody know the other two answers? Yeah, what'd you say? So did you do those in your head? Okay. So what did Orion actually do in his head? He thought to himself, what will make 2x plus 8 equals 0? And he knew in his head 2 times -4 would give him -8 plus 8. Some of us might not be able to do it in our head, So we should actually write out that we would subtract 8 to the other side of the equation and divide by 2 on both sides, and then I would get -4. So if you see a coefficient, does anybody remember the shortcut from quadratic world? Basically, what are you doing? Subtracting this 8 to the other side and dividing by 2. How can we use that shortcut on the other factor? We would add 3 to the other side and divide by 7. So 3/7 is the other x-intercept. So I would star example 4 and 5 for yourself, understanding that the 2 doesn't contribute anything new, and that these you would actually have to solve out. What about example 6? Yeah. How did you figure that out? What did you do? Did anyone try to put it in factored form? Oh, okay. I'm looking at number 6. I can't tell anything about number 6 right now. But I did learn how to factor this year. And so if in standard form, does anybody remember the diamonds method? What are the factors of -4 that would add up to +3? Can anyone think of any factors of -4 that would add up to +3? So couldn't I factor this x plus 4, x minus 1? How many people remember factoring? We did it this year. It was unit 3, I think, or unit 2. Unit 3, I think. All right, well, we might need to review factoring quadratics. What would my 2 x-intercepts be now that I'm in factored form? Close. -4 and +1. So the factors are opposite what the x-intercepts are. So number 6 required some factoring. Number 7, Orion, you were giving those answers. Can you say them again? Did people get that one okay? When there's an x in front, it could be 0. +3, +1, -0.75. Okay, what about this last one on number 8? This is another good example of what to look out for. X squared minus 4. Did anyone do that in their head, or what did you get for your answers? 2 is one of the correct answers. What's another answer? -2. Why does this quadratic have 2 different answers? I'm also going to put -9 so I don't forget. Does anybody remember from studying quadratics? What do you do to solve this quadratic? Add 4 to the other side, right? Add 4 to the other side. And what do I do next to solve for x? Take the square root of both sides of the equation, and remember that gives you 2 possible solutions. +2, because 2 times 2 is 4, and -2, because -2 times -2 is also 4. So I feel like we studied this year in Algebra 2. My incoming students into this curriculum, I'm really hoping their Algebra 1 curriculum gave them a strong basis of working with these functions. I would like you to try number 1 under Are You Ready for More for a minute. It says write your own equation that is true when x is equal to -5, 4, or 0. And try number 2 as well. To me, these are ones we should be able to do. They're not an extension for us. We need to be able to write the equation ourselves, model it right after either like number 7, number 5, put your parentheses. What goes in the parentheses? They're giving you the x equals this time. You're coming up with the parentheses. So you should be able to do this forward or backwards. This is what I do when I make up a test question. I think about what I want my answers to be, and then I write the factors. What would you say for number 1? How do I get 0 to be one of the answers? I need an x out front. What is my factor going to be if -5 is the answer? X plus 5 in parentheses. And what is my factor going to be here if 4 is my answer? What goes in the parentheses? X minus 4. Do you think you could do that either way? From the parentheses to the x-intercepts, or from the x-intercepts to the parentheses? All right, what is tricky about number 2? They still want -5, 4, and 0, which is exactly what I had in number 1, but they want the equation to be a 4th degree polynomial. What degree am I at so far? What degree would this be when I multiply it all out? Would it be x squared, quadratic? I have an x times an x times an x. So what degree am I already at? A degree of 3. How can I make this a degree of 4, but it says I have no other values of x as my answer? Yeah, make one of your factors a quadratic factor. So in this case, I could make that like x squared. I could make one of the other ones squared. So see how we jumped from here to here? I'm at a 3rd degree, now I'm at a 4th degree, but I didn't add another factor of x. So I feel like all of that you really need to understand well for our final exam. It's all dealing with the factors of a quadratic. We're taking it one little step further into the world of polynomials. Okay, so the next one says it's a card match again, and you're going to match it to a graph or a description. So take turns with your partner and explain how you match. Okay, so a couple examples. Let's do 2 examples. So example and zeros, which are x-intercepts, in case you forgot that's what a 0 is. So on day 5 learning target, let's just add 2 examples and then what were the x-intercepts. So a good one to add would be 2 times x plus 1 times x minus 2. What are my 2 zeros for this? So for this polynomial, I'm on the learning target day 5, so you have to know what to use on your final exam. What are your zeros? What are your x-intercepts from this first example? Who can tell me what they are? -1 and +2. Let's add one where you've got x, 3x minus 1, and x minus 7. You're going to tell me what the x-intercepts were. I guess I should kind of like make this a table so that you can kind of could have made it a rectangle. Bad planning. This is an example. These are the x-intercepts. -1 and +2. To show you that this 2 didn't do anything. So actually, I should have probably made this coefficient not a 2, because the whole point was I wanted to show you that this coefficient did not contribute, and you might get confused because there's a 2 over here. Let's just make the coefficient an 8, so that you're showing that the 8 did not contribute an additional factor. This 2, in fact, came from this factor of x minus 2. I want you to know that the number in front, that's a stretch factor. It's not giving you another x-intercept. All right, what are my 3 x-intercepts for this problem? X could be what, and what? When there's an x out front, it's 0. All right, what do I get from this 3x minus 1? Maybe you want to write down 3x minus 1 equals 0, and remind yourself how you would solve for x by adding 1 to the other side and dividing by 3. And then the other one would be 7. If you don't want to write down how to solve for it, but you want to see how to solve for it, that's fine. But I just talked to a couple different groups that didn't know what kind of solve this for the x-intercept. So if you want to write down how to solve it for x, and then you've got your 3 examples, I think that's good.